is Stats 2023, Chapter 8, Section 4, 2 Sample Testing. This is the last section that we'll cover in this chapter. This is difference between proportions. This is going to be on your calculator a two-proportion z-test. Just a reminder, we're dealing with P now, which is the population proportion. The three null and alternative hypothesis combinations do not change. Got equal, not equal to, less than or equal to, greater than, less than or equal to, greater than or equal to or less than. Make sure you understand that the alternative does not ever have an equal. Okay? For these two sample proportion tests, they must be random, they must be independent. You must check that sample 1 times proportion 1 is greater than or equal to 5. Sample 1 times the Q1 is greater than or equal to 5. Sample 2 times proportion 2 is greater than or equal to 5. And then sample 2 times Q2 is greater than or equal to 5. Remember, Q is nothing more than P1 minus P. So if your P is 20%, your Q is 80%. Going to example 1, which is on page 449 of your textbook. It says that a study of 200 randomly selected occupants in passenger cars and 250 randomly selected occupants in pickup trucks shows that 91% of occupants in passenger cars and 83.2% of occupants in pickup trucks wear their seatbelts. Okay. At alpha 0.1, can you reject the claim that the proportion of occupants who wear seatbelts is the same for passenger cars and pickup trucks? So right away, we can see that our null hypothesis is that the proportion for cars is equal to the proportion for trucks who wear seatbelts. That's our claim. If our claim is equal to, then our alternative hypothesis is not equal to. In other words, we don't know if the cars is less than or greater than, we just want to know if there's a difference. The alpha is at 0.1. Now these problems here, you got to understand the relationship of N1, P hat 1, and X1. Because you may get problems where they give you N1 and P1, P hat 1, you got to find X1. And they may give you N1 and X1, and you got to find P hat 1. Okay? So remember that, if I take P hat 1 and multiply times N1, I get X1. If I take X1 and divide by N1, I get P hat 1. So they're related. They're related. Same thing with the second sample. Okay? Next, we go to the calculator. And on the calculator, we're going to go to Stats. And we're going to move over to Test. And see at number 6 where it says 2 proportion z-test. That's where we're at. We already did the 1 proportion z-test. Now we're at the 2 sample z-test. Okay? Or 2 proportion z-test. So I'm going to hit number 6. And when I hit number 6, I'm going to put these numbers in. Notice that all it's asking for is X1 and N1. That's the reason I was telling you the relationship of being able to find X if they give you P and N. Okay? All you got to do is multiply N by P. So if we plug these numbers in, we got 182 and 200. So our X1 is 182, and our N is 200. And if we come over here, our X2 is 208, our N2 is 250. Okay, so notice that in this particular test, all we need is X1, N1, X2, N2. Now, our alternative hypothesis is not equal to, so we want to make sure we tell the calculator that. We move down to calculate. We calculate, and we get z as 2.4, and I round it off to 2. We get our p-value of 0.016, and again I round it off. We can see that this p-value is less than the alpha of 0.1. which was given to us in the problem. So with P less than alpha, we reject the null hypothesis, and there is no support for the claim, because the claim was that they're equal. So there must be a difference between the two. Okay, now we're coming to example 2. Example 2 says, a medical research team conducted a study to test the effect of cholesterol-reducing medication. At the end of the study, the researchers found that of the 4,700 randomly selected patients who took the medication, 301 of them died of heart disease. Of the 4,300 randomly selected patients who took a placebo, remember a placebo is same looking pill but doesn't do anything, it's really a sugar pill, 357 died of heart disease. At alpha 0.01, can you support the claim that the death rate due to heart disease is lower for those who took the medication than those who took the placebo? So right away, our null hypothesis is that those who took the medication is greater than or equal to those who took the placebo. Our alternative is those who took the medication is less than those who took the placebo. There's our claim. Our information from the problem, N1 is 4,700, X1 is 301, P hat 1 is 0.064, N2 is 4,300, X2 is 357, P hat 2 is 0.083. Okay, hope everybody realizes that this is about 6% of patients that died, this is about 8%. Okay. If we go to the calculator, remember alpha is 0.01. Go to the calculator. Again, we're going to do the 2 proportion Z tests. We plug 301 in for X1, 4,700 in for N1, 357 in for X2, 4,300 for N2. Our alternative hypothesis is less than. So now I'm going to move down to calculate. When I calculate, I get a Z. And again, I'm rounding these Z's and P's off. So I get a Z of negative 3.25. I get a P of 0.00057. Make sure you understand. And when you get this, anytime you get a number that looks like this on the calculator, that E means times 10. So this is really saying 2.75 times 10 to the negative 4. All right. So what happens here is that when you look at this, that negative 4 means that we're going to the right of the decimal. But we start our number, the 2, on the third, after the third zero. So 2.75 times 10 to the negative 4th is really 0.000275. Notice that the 2 is in the 4th decimal place to the right. This says negative 4, so that negative 4 is telling you where to put the first number in the 4th decimal place to the right, which is what we did here. So if we look at this, we can see that our p-value is much less than alpha. So with p being less than alpha, we reject the null hypothesis. And there is support for the claim that this medication did reduce the number of deaths compared to a placebo. Not compared to any other medicine, but compared to a placebo.